My name's Han, and I'm 25 years old, living in Australia. I grew up in China with my parents and grandparents. I'm currently a PhD student at Department of Electrical and Electronic Engineering at the University of Melbourne. My first time get interested in science is when I was 6 years old. My dad bought me an electronic kit. So this is including a lot of electronic stuff where I can build different circuits on an open working circuit board. For example, I can follow the instructions to make lights or speakers or other things work. So at the beginning, I was just following the instruction to build up different nodules. And after a few months, I started creating those circuits myself and building different projects. That's the first time I get interested in science. I think all the greatest advancement of the human history, it came from the discovery of the scientist, because we want to find the betterment of the mankind. I want to contribute to build up a sustainable society where my grandchildren can happily live in. I'm very worried because global warming is real, and I think people should do something about it. My grandfather started teaching me mathematics even before I went to the primary school. And my dad is engineering, and he always explained me how those electronic devices works. So that's how I become interested in science. And also my mom, she encouraged me to go into the science and become a scientist. I think a scientist is a person who works in the field of physical or natural science. However, in my opinion, besides this, a scientist should also care about society and humanity. I start my day at 6:15 a.m. and I will go to gym and get ready for work and ride my bike to office, start working before 8:30 a.m. And then I will have lunch at 1 p.m. And continue working to 6 or half 6 p.m. Then I will go home and make dinner and having some rest. Climate change is real, and global warming is happening. To fight against global warming, we want to decarbonize our energy systems. There are a lot of ways to decarbonize our energy systems. For example, we can build renewable energy resources such as solar and wind. We can also build distributed energy resources such as our rooftop PV and home-used batteries. Once we have clean electricity, we can use those electricity to electrify other energy sectors too. For example, heating, cooling, and transportation. However, it is not as simple as it sounds. In power system, we want to keep the supply meet the demand at all the time to maintain the system's frequency within a certain bound. For example, 50 Hz or 60 Hz. Our utilities, generators, and devices are all designed to operate efficiently within this certain frequency bound. And when the supply doesn't meet the demand, our frequency changes. And we face problems when the frequency is not stable. That's why we need to form kind of flexibilities in the power systems to keep the balance between supply and demand. This is traditionally done by those fossil fuel-based generators, which is currently being replaced by renewable energy sources. So imagine you living in a power system that is fully powered by renewables. In a really hot summer day, there's no wind blow and everyone is turning on their air conditionings. The supply wouldn't meet the demand and the frequency will drop. And then you will have a power outage. No one can use electricity again until we fix it. So that's why it's really important to keep the lights on when we're changing the power systems. I work in a research group where we have a few PhD students and my professor. So our topics are all carried out based on this background that energy system is changing. However, we are all specialists in different areas and trying to answer the question from different perspectives. My research is trying to answer how can we successfully and economically integrating those emerging technologies such as renewable energy sources and distributed energy resources while keep our lights on. So in my research, we found that one way to address this problem is to exploit the flexibilities from customers' participation. Yeah, another word is from us. I want to use my knowledge and my models to help our energy systems to transit towards to a low-carbon future. This is a very big problem because nowadays we want to decarbonize our energy systems to reduce carbon dioxide emissions. So everyone starts building the renewable energy resources. It's not that simple. We need to do it in the right way, not to just simply replace all the fossil fuel-based plants with clean energy. The reason why I choose my project is because I always want to use the knowledge that I learned at school from physics and mathematics to deal with some real-world problem and really help us to achieve a better future. So the first case is from some bad devices with a very low efficiency. For example, the devices with low energy ratings, a very old air conditionings, or even a house with bad insulations. So the second case of inefficient energy use is from the human activities. We are operating the devices in an efficient way. In my research, we try to exploit the flexibilities from customers' participation. So we built up a model that can optimize the operation of different devices and technologies to achieve a certain goal. I think the biggest challenge of my research is the gaps between academia and industry. And to overcome this, I think from our perspective, we need to learn more from the industry and have more collaborations with industry. And from industry perspective, they also need to listen to us and exchange the ideas with us. To make science stronger, we need to listen the voice from the scientists. So sometimes the peer-reviewed statement from scientists might make you feel uncomfortable. However, don't put your head in the sand, but look at the fact and listen to their voice. So my role model is my supervisor at the University of Melbourne. He's also the person who guides me into my research. He is a very knowledgeable person and he always have a lot of really good ideas. So after I graduate, I want to stay at the university to inspire and teach and guide young students in their journey of science. But besides that, I want to collaborate with industry as well so that I can do some real-world implications using our knowledge and science. So as long as people still use electricity, I will be working in the field of energy systems. Also, I want to use my knowledge and my model to make some real-world changes and to make some real-world implications. So my opinion is, if you are interested in science, just go for it. Don't be afraid. At least try it and keep your interest. There is nothing to be afraid of. I am a very optimistic person, so I still believe that we have this little chance to give our grandchildren a sustainable future.